Hello, everybody. I assume speaking in English is okay for you because we have, I think, millions of other visitors, listeners outside in the internet because this session is streamed. And yeah, I was already introduced. So this was the wrong button. Which one is the right one? Welchen muss ich drücken? Der große grüne. Nee. Ach, der. Okay. Alles klar. Okay, one advantage for the English language is we have in German only one word. We have only the word Sicherheit. In English, we have two different meanings of Sicherheit. One is security and one is safety. So I'm from TÜV, so normally you combine TÜV with the safety aspects. That means preventing threats from machines to human people. The security part is completely different because with security, you have to do with people who want to attack you. This means our enemy is always a human being. And that's why also governments or organized criminal things are our threats. This is the background. That's why we have heard very good examples now in my preceding talks about use cases in 5G. And I don't want to repeat them, but what is possible. But one is very important, and this is one constant. With no ICT, you don't have digitalization. Yeah? This means information and communication technology is a binding factor where all the digitalization is making possible. But the other thing is also valid. Without IT security, you don't have all these business cases. They may work, but maybe not very long. And the question is how long they are accepted. That means without security, you don't have this digitalization and also not the threats. How is this in today's networks, LTE networks? We have a so-called 3GPP. This is a 3G, third generation partnership project, which has specified the interoperability between systems. And this is then specified here in this example. But there's, of course, the network operator who has to deal with much more, which is completely not specified in 3GPP. This is all the perimeter security, the network zoning, traffic separation, which is necessary, secure operation and maintenance. All these aspects are outside the system components you are purchasing when you have a vendor who is selling you the 5G equipment. This is the task of the network operator, and just thinking on private 5G campus models, this is then your task to deal with those things which are here in the middle. And then the network component itself is in 4G, of course, hardening of those components, that no attacker can get access to the functions and to malfunction this. In 5G, we have now a different situation against 4G. We have in 4G dedicated components with dedicated functions. In 5G, we have virtual functions. We have software-defined networking. This is all cloud technology which is used, and this is a complete different aspect and approach to this. And this is a major difference, which is also then an aspect which needs to be considered when you speak about the security aspects of this. This is all cloud technology, what we are speaking, virtual functions. There is a so-called NGMM, Next Generation Mobile Network Operators, which have recognized in the past with the former networks that there are a lot of attacks possible to those infrastructures, and they made a lot of requests to the next generation, that means the 5th generation, what should be improved there to prevent the attacks. There were several things, and you always need to consider 5G is an evolution of 4G. So it's not a complete new thing, it is an evolution. And that's why also this 4G security aspects are inherent in this. So before, it was recognized that you have a lot of attacks already on radio interfaces, on the signaling plane, on user plane. You have aspects which are known from the internet, masquerading, privacy, threats, replay, bidding down man-in-the-middle attacks, and interoperability security. I pick one out of this out here. This is this bidding down aspect, which is maybe not that known, but in the communication world, very important. Bidding down means in the communication world, you have always an opposite side which you're communicating with. And you need to negotiate with them what are the capabilities. Do we have this capability? Can we speak on that level? The same is, of course, in negotiating the security aspects. So if you have an opposite part, which is a high security level, and you also have a high security level, then you can speak on this high security level. When the opposite side has no high security level, of course, you need to go down. And bidding down is an attack, which is exactly simulating such negotiation and is forcing the both parties to bidding down. That means using the lowest security mechanism. And this is a very successful attack which was recognized. It is of course a big threat because you have a lot of security aspects implemented in your network and in your environment. But if this bidding down attack is successful, then you don't have security in the network communication. So this needs to be considered. This was recognized, and that's why a lot of improvements are done here. We have also seen in the previous presentations that we have the user services on the one hand side and we have remote services. So not 5G is the, let's say, the network itself. It is, let's say, user services which are in the cloud or at special servers. And the mobile network operator is somehow only a transport for these services. That means when you want to have the full security, you need to have the security on the application layer. 5G network, if it is very much secure, does not help you in that much. The mobile network operator has also own services, of course, and has its own 5G infrastructure. This 5G infrastructure is, as I said, then capable to have different services. We have seen this in this triangle, so I don't want to repeat this again. You have now the possibility that you don't only have one service for all, you have very specialized services which you can assign, the so-called network slicing, to special purposes. And this part of the network components itself for 5G is defined in the 3GPP. The other thing, that means what the tasks of the network operator are, this is defined on national network agency regulations. The BNetzA in Germany, for instance, is responsible for this, what is allowed and what is the demands for the mobile network operator. That's here. But the end-to-end security is the task from the user and the application. Now we have this new model with the 5G campus. And there's, of course, another possibility. You can combine your private network with a mobile network operator, with a public network operator. Yeah? You can use this way to use the services. But you can also do this directly. And the other possibility is that you have no access to the outside, which is, of course, the highest security level you can ever have. No access to the outside, but, of course, limited functions then. One example, because when we speak about security, you need always to speak about examples, because maybe you are not the security experts, you don't know the threats which are possible. I give you one example from industrial security. From the past, these are, let's say, industrial equipment, network plants, there's a control center, and they are all combined for years already with a dedicated network. No access to the outside, very complete, dedicated. Everything is fine. But even in this scenario, you have the problem with maintenance people. They are coming from the outside, they maintain the machines, they come with their PC, with their USB sticks, and implement something what you as an operator don't know. So this is one threat, of course. The other thing are remote monitoring of machines. Every producer of machines at the moment is monitoring its machines remotely with dedicated things. Then, of course, internal threats. There's also the bad guy in your company. He can also get access to this because perimeter security is good, but when you have somebody internal, then you have this problem that also he gets access to this. Then with the, let's say, digitalization, you go into combining the operational IT with the normal IT. Yeah? That means you have the possibility from your PC to control all the machines. And here, of course, is also the possibility that somebody is threatening this by malware. With digitalization, we have now cloud services, the access to the cloud service, and with this you have, of course, then also the possibility that somebody is remotely getting access to your things, because in the machine area here, and the machine parks, there is a lot of very old software and very old operating systems in use. Everybody knows this, maybe you or yourself in your environment, there's still Windows XP in use because the programs which are running on Windows XP for the production company is not existing, you don't get an update of your software, you have the problem. As long as it's running in a dedicated network, no problem, but when you are opening to the outside with cloud services, then you are visible. That means you need to really rework your system that those things are then in a separate network and not accessible by the outside. Question is, of course, what is with 5G now? Nothing. The same threats are there. Yeah? All the network issues are now replaced by a 5G network, but you have the same threats. And there's even something more, because you are now combining, let's say, not with fixed line networks or Wi-Fi. You have now everything combined with a radio network. And that means jammers are a new problem. They can very much disturb your environment, and they are very small. That means you need to identify where are the jammers at the moment, who is disturbing your frequency spectrum, or is even occupying some parts of your frequency spectrum, which is, of course, a very big threat. And the other thing, of course, drone attacks. We have in the afternoon, I think, some other presentation. This is, of course, then also a threat which is to your production line. So these are the examples to make you aware about the complexity of this. So 5G, if it is secure, it is only internally secure. So you need to do still a lot of things around this. Then the attack of the smart toaster. Maybe somebody remembers 3 years ago. The new attack methods are not that somebody is alone attacking, let's say, a server. Now, hackers are influencing with malware the IoT devices. And the IoT devices have the same build, the same, let's say, vulnerabilities, and they can be influenced and used as a botnet to attack, let's say, then immediately a service. This was happening 3 years ago in the United States. We have a similar attack also in Germany here, where a lot of important services were down for several hours up to days. The same, of course, can happen, why do I say this, in your environment. When we have this service, massive machine type communications, that means millions of devices, especially sensors, can now communicate with the 5G network, and they will be used. Up to now, it is not possible because Wi-Fi has limitations, fixed line network has limitations. With the implementation or with the use of 5G, you have much more possibilities to equip millions of sensors in your production environment, and this will happen. This is definitely, for me, the most acceptable use case, which is a big advantage of 5G. Sensors will have a low battery lifetime, no big power, but exactly 5G, massive machine type communications, this service is exactly tailored to that threat. But of course, this threat can be used by some hackers then for the same purpose, for attacking then your 5G infrastructure. Just as an example. That means also the prevention from so-called DDoS attacks, the dedicated denial of service attacks, is an issue which you need to solve. This can be solved on the one hand side by the vendor of the 5G implementation, because there's also a very big demand from the community that these DDoS attacks need to be recognized very early and need to be prevented. But as an operator, you need also to check this. That means you need to look for anomalies in your network, to monitor this permanently, to identify this very, very early. This is an example. So in 5G, we have then the same. There is a specially description of 3GPP for the security architecture, and then things which are not specified by 3GPP, which is then done in the task of the mobile network operator. Plus also then the new function. As I said, we have virtual functions. We have no dedicated functions and special components. We have virtual functions and cloud infrastructure. And these security mechanisms, which are already in place today for cloud providers, need to be implemented in the 5G infrastructure for the vendors. These are the 3 steps. There's also one thing. This is a picture from 3GPP standardization, which says that you have, let's see, 2 major domains. This is a user mobile equipment on the left-hand side. This is one security domain, and this is not necessarily a mobile phone. Yeah, that can be a sensor which is transporting any device in the IoT. And on the left-hand side, on the right-hand side, you have all the equipment layers towards the core, from the radio access to the core. And for me, not understandable is that 3GPP has defined that the security approach is decreasing as closer you come to the core. That means very high security demands on the access network, on the radio part, but towards the core it is decreasing. When you are in this environment where I am, you cannot understand this, because even the core and all the aspects, you can attack them directly, is not the way. So this is something in our evaluations of 5G components and 5G software, which will very hard evaluate it on that. So as I said, 3GPP is specifying a lot of the security mechanism from all the history of the former releases. So in release 15, there's a security architecture and procedures for 5G systems. This is now going very technically, but there are 8 major aspects which are covered by this security architecture. A lot of attention is done to the authentication process, authentication and key negotiation process. So we have a primary authentication, which is already there in 4G and LTE. But we have now an enhancement. There's a new extensible authentication protocol, which is in use, which is not existing in 4G. And this is then has to do with, let's say, authentication of equipment or of devices which are running in your network, which have already been authenticated by a remote network. And that you have, as an operator, the control to this authentication, that you do a double authentication. That's why also secondary authentication. This also has to do with the evolution. That means 5G is an evolution of other networks, and it also includes other access methods, like Wi-Fi, for instance. Yeah? That means you need to have a special authorization methods, because it not necessarily is a device which is directly connected to your own radio. It can come over a Wi-Fi access. So you need an authentication, and you also know that devices can have several connections to different areas. And this is then solved in the secondary authentication. Inter-operator security has to do with diameter and SS7, the signaling protocol where a lot of attacks have been recognized. Then privacy threats, which are improved, because stealing of the identity is the most attractive issue what we see at the moment in our security evaluations. Then, of course, considering the service-based architecture, this is the software-defined network, the central unit and distributed unit. In 5G, you have a split of the base station in 2 components, the central unit, which is then connected to the radio, and the distributed unit, which has no access to the user. Key hierarchy and the mobility aspect. And all these aspects, let's say, are defined by 3GPP, and they are also, let's say, to be tested. Our question always as an evaluation company and certification company is, how is this implemented? So this is definition, this is, let's say, the framework, how it is to be implemented to assure interoperability, of course. But of course, the big question is this correctly implemented, or can it be bypassed somehow, or can it even be misused? This is in our task. So we have here from the 5G infrastructure a lot of areas. I don't want to go in detail to this. I have 1.5 minutes only. But a lot to say is, of course, clear. You cannot cover this hot topic in 20 minutes. There's a lot to say to this. But to have here an overview, and maybe afterwards you get the slides anyway, you can have an insight. A lot of things have to do with authentication and also authorization, access, because you have to do it with millions of devices. So this is a big issue which need to be covered here, and all the aspects of the cloud infrastructure security would need to be implemented. So the complex 5G security targets ecosystem on the case Germany. On the lower hand, we have the network developer, the network vendor, and the developer of mobile devices. This all, as I said, is covered by 3GPP. And they also have an own evaluation layer. This is called NESAS, Network Equipment Security Assurance Scheme. This is, let's say, the scheme which is necessary for a vendor of 3G equipment to get the allowance to sell the products to them. Then we have the network operator. Here in Germany, we have the so-called Telecommunications Act, Telekommunikationsgesetz, and there's a paragraph 109, which is defining the requirements to the network operator, which need to be fulfilled. Especially here, this is of course controlled by BNetzA, and with 5G, we have the difference that now is at the moment in work is a catalog of so-called critical core components of 5G. And they need to have a certification from the BSI. It is not defined finally on what kind of certification will be done. It will probably based on common criteria, but this is a new thing that this new catalog will be published, and then all network vendors need to undergo this certification of core components. This means also will be a certain delay on the rollout for mobile network operators, which are obliged to use these components. At the moment, there's no definition for campus networks. So I assume this will be an advantage for campus networks to run earlier because there is no certification at the moment necessary. Okay, this is the catalog, what I told you. I have seen today in the news, the catalog will be published very soon. Today there is from the European Commission a so-called 5G cybersecurity risk analysis from all the countries. So every country at the moment is bringing in the risk analysis because they are rolling out 5G networks, all of them with, let's say, international vendors. And then the threats calculation is at the moment, so we will see what's coming out. And this, of course, is a contribution here of Germany especially. So I think this is a lot of things which need to be considered in this environment. What is at the moment the proposal for this? The operator needs continuous monitoring of the network traffic and to identify anomalies, and also taking suitable measures for protection, even preventing the traffic if somebody disturbs. Then, as I said, the critical core components, which need to be certified by BSI, are responsible. You need to have skilled people and trained people, specialists. This was not before a demand, but now it will be. And you also need to have enough of those people, which will be a problem, of course. Then, of course, proof of exclusive use of tested hardware and source code at the end of the supply chain. That means what is certified needs to be at the end also implemented. That is the supply chain monitoring is very important, and also the trustworthiness of the mobile network of the 5G vendor is a big issue. Yeah, and maintaining sufficient redundancies for critical core components is clear, but also a demand that you use components from different manufacturers. Multi-vendor networks. This is a demand from the so-called Telecommunication Act for public network operators. It's not necessarily for the campus networks. So with this, I think was a brief overview to this. We have maybe later on some questions.
A small bridge for you.
Sure.
You have such tremendously information for us. Yeah. Maybe you are here for the one or the other talk sure. outside, and maybe one who is very interested in your topics may have a coffee with you. What we can see is, first of all, your applause for your presentation and the deep insights in security. Thank you again. What we can see, that's a very complex topic, yes. And it's not you showed from the beginning, from the security issues we had already in the past and we will have in the future, and that's not really an easy topic, and it's not easy to tell it all in 20 minutes. Yeah. When I look at the perspective of a user, of a end user, what is the way? How can I get an idea when when there is a problem? Maybe I think it's just a technical problem, but in truth, it's I'm under attack by some outsiders. How can I see it? How can I measure it? Or
reality is that in most cases you don't recognize this, because a theft of data is let's say just a copy aspect. That means the data is still there, but somebody else is using it on the other side. So this is very difficult.
But if there is a denial of service attack, yeah. for example,
then of course you have service outages. You will see this immediately, and you will call your IT administrator, and in this case, the mobile network operator, the 5G operator. and they need to have measures, and this is very a key of the new catalog of the Telecommunication Act here in Germany, that there's a lot of new obligations for the network operators to prevent those attacks and identify those attacks. Permanent monitoring is a very important issue. And you need, of course, equipment and tools and also skilled people in the operator side who are able to recognize those threats and to be able to react on this. But at the end, as a user and application, 5G is just a part of the transport network. It's not the whole chain. That means your user service and the servers at the other side also need additional security.
But if I want to go the step, I have to open to use, for example, new business models, and then it goes hand in hand with implementing 5G. With a look at, for example, DLR is showing the autonomous car driving in Hall 17. Or another example from the process industries we mentioned earlier, the pharmaceutical industry, for example. They need certain documentation and they must be 100% safe, that they have a safe network. Can you support these users with a certification, you are safe and you won't be hacked?
That's correct. This is possible. As I said in the beginning, you have to deal with the unknown. That means risk-based analysis. What can happen to your application is very critical out of you. You need to test this, really. And one test method is penetration testing. And this is a service what a lot of companies, also TÜV IT, is offering. And it's a big recommendation to understand also penetration testing as a process. This is not a one-time issue. You need to permanently check from a third party.
What is the frequency? Once a year, or
it is normally every 2 years.
Every 2 years. Okay, but you won't reach 100%. I think. How many nines after the point will you provide?
We can talk a day for this. It depends, I would say. It depends very much.
Okay, we have no day left.
One example, if you have a vendor of a service who is implementing completely proprietary crypto algorithms and things, which is on his mind very secure, then we as the testing institute have a problem. So we normally use already certified and, let's say, internationally agreed security algorithm. And if you implement those modules in your solution, then it's very easy to test this. It's also easier to implement this.
Okay. So we will talk about this later, having a coffee. Thank you very much for having you here, and warm applause for you again for your insights.